Hi, I'm Tim. I'm here to talk about Lake Tahoe's clarity and how our snowpack affects clarity. The UC Davis Tahoe Environmental Research Center has been monitoring clarity since 1968 by lowering this simple device, a Secchi dish, down to Lake Tahoe. But what does the Secchi dish tell us really? The information this piece of plastic provides is very straightforward. It tells us how far down into the water column we can see this disc on this date and time. It's when we combine that information with other instruments and other data that we can really start to piece this information together. So let's take a look at the data. Turk researchers take measurements approximately every 10 days, and the average of those readings in a year results in an annual point on this graph. What do we see happening on this graph? We can see, based on our trend line, or line of best fit, that Tahoe is steadily losing clarity up to about 2000s. In fact, it was losing an average of a foot per year. But then we see that clarity begins to level off. What happened during that time that may have caused this type of improvement? If we look back 20 years ago, we can see that 1997 marked the very first Tahoe Summit, which sparked into the Environmental Improvement Program, which aimed to protect and improve the environmental health of the Lake Tahoe Basin. Projects include everything from new trails to creek restorations to programs to protect the lake from aquatic invasive species. So our data mirrors the collaborative effort of local, state, and federal government agencies, private entities, scientists, and the Washoe Tribe of Nevada and California, showing that this effort has potentially altered the once steady course of clarity loss. Now let's look a little closer at the data. We can see that there's almost a cyclical change of clarity every 5 or 6 years. I want to examine this period between 2012 and 2016. We can see such a continued and somewhat dramatic improvement in clarity. But then all of a sudden, there's 2017. It's not only a loss in clarity of about 9.5 feet, but it's also the worst annual reading ever recorded. So what happened? Perhaps some of you may recall, in 2012 to 2016, here in Tahoe, we were experiencing record drought conditions that were so dire that we were dealing with state-mandated water conservation measures. One of the silver lining of drought is improved clarity, because rather than precipitation flushing fine particles into the lake, the fine particles just stay on land and clarity continues to improve. And then what happened in 2017? We had one of the largest winters on record. Record amounts of precipitation means a large flushing on the year's sediment that has been stored during the years of drought. But how does the snowpack relate to this? Well, there's a lot of precipitation in the water year 2016-2017, but not all of it came as snow. We had a lot warmer precipitation, which was part of the reason why clarity was so bad. Traditionally, our precipitation comes as snow, which means there isn't an immediate flushing of the fine particles from the mountains into the lake. Rather, the snow sits and eventually begins to melt in the spring, filling the streams, feeding into the lake with icy cold water. The temperature of the water is key. Cold water is denser than warm water, so icy stream water, loaded with fine particles, normally will sink in the lake until it hits icy water of the same temperature. But if the precipitation comes as warm rain, it will flow into the lake and float on top of the cold water with any fine sediments it has brought with it. Warmer precipitation compounded with years of drought ended up creating conditions for the worst clarity on record. There are a lot of stories to be told with this data available, but all you need to do is a little research. Join me next time when we discuss the difference between winter and summer clarity.